Okay, good morning, everybody. Welcome to FuzzCon Automotive Edition. I'm really glad you're all here, and we have an exciting lineup of both industry and academic talks for you today. My name is Matthew Smith. I'm a professor of computer science at the University of Bonn and Fraunhofer FKE, and it's my pleasure to guide you through today's talks. I want to keep it short and sweet, so I'm going to pass the mic over to Sergey, who will give some introductory words from our host, Code Intelligence, this morning.
Good morning, everyone. Just a sec. I'm sharing my screen. You should see the slides now, right, Matthew? Okay, so okay, thank you, Matthew, for the introduction, and welcome everyone to the FuzzCon Europe Automotive Edition. It's great to see that many people connected here from all over the world. I just read that there are people from Singapore or Tokyo, and the amount of people also shows the interest for fuzz testing, secure development, and DevSecOps in general for automotive. I'm especially proud for the great lineup today, and thus a big thanks to all the speakers today. Without you, it wouldn't be possible to host this event. But also a special thanks to my team who helped me to organize this conference. And actually, it's not our first time doing this event. It all started 2018 with a meetup in Bonn where we decided to host a real conference, which we indeed did in 2019, starting with the event What's All the Fuss About, with around 60 people in Bonn. And this September, due to the pandemic, we had to switch to a virtual conference, giving us also the opportunity to make this event a bit larger. And we hosted a full day event with more than 1,000 registrations, and at the peak with 700 people online at the same time listening to the talks, which also is shows a huge interest in this topic. And there was the focus mainly on research and coming with the research and industry together. And the researcher part was about 150 people, and all the other people came from the industry. And a big part of it was from the automotive industry, making it around 200 people in total. And after this event, we get a lot of requests and feedback from automotive, basically asking us questions, how would this work for automotive? And thus we decided to host an event focusing on automotive only, and in a shorter term, basically that we only have 3 hours where we focus on the challenges, but also on the specific demands in automotive and secure software development. So who am I? I'm Sergey, one of the 4 co-founders of Code Intelligence. And before founding Code Intelligence, my work and research was mainly focused on usability research. And also I worked as a software developer in automotive, and later switched to the university and Fraunhofer to do research in secure software development. And in our research projects, we worked closely with the industry, some parts of the industry coming from the automotive sector. And we had a key observation there. When we analyzed all the software source code from the industry, we found that most of our bugs have been found with fuzzing, but fuzzing has not really been adopted in the industry. And this is how Code Intelligence got founded. We decided to found with the vision that we enable companies to easily integrate fuzz testing into their software development process. And what to expect from today, based on the name FuzzCon, it suggests that fuzz testing will be probably a big part of that. And there is a clear trend that fuzz testing is on the rise. So outside the automotive industry, the first tech leaders, such as Google, claim that they find 80% of their software bugs with fuzzing alone, giving it the other 20% for the other approaches, at least for some specific projects. And one of the most prominent examples is the Google Chrome project, where they found more than 20,000 bugs in 2 years alone, and this in an automated manner, with a few people setting up the entire fuzz testing process. And this also shows the capability or what can be achieved with fuzzing. And there is a huge trend that more and more companies are going to this trend. But what is so special about automotive? Automotive is basically an old-fashioned industry, and at some point they implemented all the processes in the V model, basically showing that you have a very strict processes for the development, and then it comes to the Q&A department, and the quality and assurance ensures that the quality is all right, and then there is a kind of feedback loop. But if we look to the trend to the other industries, they implement a more modern, lean, DevSecOps-oriented process, saving tons of money, which would be also interesting for the automotive industry. And it's not surprising that this is something what the automotive industry is also thinking about. And most of the players there are moving to the new kind of processes. But it simply doesn't work out of the box. There are regulations, some specific automotive differences, and project scopes which don't let DevSecOps work out of the box. And today's talks will cover on all the lessons and all the results achieving in the sec part of DevSecOps. So basically, the focus today is on the sec part of DevSecOps. And we also will talk a lot about the different tooling, about the different challenges, and maybe one or the other talk will also make some suggestions what a company might do to enable a secure software development. So if we have a look to the current state of the art of DevSecOps in the automotive industry, you still see that in most of the big players, there still are different departments. So basically you have a development department, you have a Q&A department, you have an operations department, you have a security department, which kind of contradicts the idea of this DevSecOps movement. But you also see that a lot of companies try still to move to the processes. And here you see that, for instance, the static code analysis is already widely adopted in the process, giving the developer some kind of feedback on his code style and what is good or bad behavior. But at the same time, we notice that most developers from automotive industry don't use dynamic testing or fuzzing at all, or even worse, they don't know anything about it. And if we look at the regulations, for instance, ISO 21343, it even states that fuzz testing should be used. And this is what is done in the security departments of automotive. So pen testers and Q&A people heard about fuzzing and mostly used the power of black box fuzzing in their testing processes. But this makes development also very slow, because once the security people find the issues in the security process, they give it back to the development, and there are weeks of how a single bug could be fixed. And if we compare it to the other industries where it's already faster, it's a kind of disadvantage. And we see a good trend that automotive is not that old-fashioned anymore. There is a clear trend that they go to the same movement. And other challenges for automotive to implement this kind of fast approaches is that they have numerous of regulations which you need to consider, and this we will hear in some of the talks, but also that there are hundreds of ECUs as part of the hardware in automotive, where you have to consider the communication between several nodes in a single car. And also, based on the history of all the processes, automotive often has a different tooling. There are a lot of commercial compilers, even own operating systems, making it kind of hard to implement that. And we will talk about that, how to overcome the challenges. So what's the mission for today? My personal mission for the future is that most software bugs in automotive will be covered in the development process, and fuzz testing will be a fundamental part of that. But now enough of code intelligence. Let's come to the most important part, our talks today, who will present what they achieved in their companies. And with that, I would like to give over to Matthew, and thank you.
Okay, thank you, Sergey, and thank you, Code Intelligence, for hosting FuzzCon again. This is a quarterly event, and there'll be different themes throughout the year, but today we're talking about automotive fuzzing, and we have a really interesting list of talks coming up, and there'll be a panel discussion at the end. The Click Meeting interface, if you want to change the language, you can do so in the right-hand top corner. If you would like to interact with us and the speakers during the event or keep in touch with us, please join the fuzzing community on Slack. For that, you can go to www.fuzzcon.eu. There you'll find a button, Join Slack Community. So please join there. There's some posts in the general channel with some information about how this event is going to be organized. and where you can interact with the speakers. So, with that, it's my great pleasure to introduce our first speaker today, Rakshit. Rakshit graduated with a master's degree in embedded systems from Delft University of Technology in the Netherlands, and he currently leads R&D projects at Bosch Research for automating security testing. The focus of his professional career has been on dependable software covering security and safety aspects in the context of autonomous driving. In addition, he represents Bosch's research activities in publicly funded projects, both in Germany and the EU level. I've known Rakshit for a good many years now. It's always a great pleasure to talk with him. He has lots of interesting insights. He's also collaborated with Code Intelligence for many years now, and I'm really looking forward to hearing him tell us why we need to rethink fuzzing for automotive software. So with that, Rakshit, the stage is yours.
Wonderful. So is my audio working fine?
I can hear you fine.
Wonderful. That sounds great. So now the screen, you should see.
And I see your desktop, yes.
Lake Clitoris, that's the snap I took. And now the slides. So.
Okay, I can see the slides. We're good to go.
Cool. So yeah, hello everyone. Thanks also for the kind introduction, Matthew. So it's a pleasure here again to represent Bosch Research, I would say. And I want to thank Code Intelligence as well for inviting me to give this talk. Now, before I kind of start off and start off with my talk, I want to share you something interesting, kind of an event that happened early this morning. This is usually the time of the day where the time now I drop my little one. She's almost hitting 2 years. I drop her off to the daycare. Today was a little bit different for her because my wife had to jump in. And as the little one was about to leave home with her mom, she started noticing me sitting in front of the screen and, staring at the screen. And all of a sudden, she started saying her favorite rhyme, which is like, Old MacDonald had a farm. And I thought that was cute. I said, okay, bye. And started concentrating on the screen again because I was next in line. And now that they left home and the house started turning quiet, I'm kind of rethinking and wondering what that moment could have meant for the little one, right? So maybe she was thinking, work for daddy means listening to Old MacDonald on home screen, maybe. I hope not, let's see. But anyway, if I were to rethink longer that there could be other different interpretations that I could come up with. But keeping this pun aside, for a while now, I have rethought about the topic of fuzzing. And today I want to share with you why fuzzing needs rethinking in the context of automotive software. So with no further ado, I'll tell you how I've structured my talk. In this talk, I would want to mainly focus on sharing our experiences which we made at Bosch Research, basically in the last couple of years, while we have tried to apply fuzz testing in automotive software. So in a sense, I will walk you through these topics which you see, starting with the motivation. What are the different motivations to fuzz within the automotive domain? And then I will talk about some aspects that make automotive software a bit different. So these are also some of the aspects that's something I spoke about during the FuzzCon in September. And after covering these two topics, I will then walk you through this main core topic of this talk, where I will focus on why we need to rethink before applying fuzzing to automotive software. And this will be the main part, as I mentioned. And I will also share, going further, some thoughts on how we could rethink and finally wrap up with some conclusions and takeaways for you. Please note that this talk already assumes a knowledge of fuzz testing, so I won't be getting into the fundamentals of fuzzing, but I will instead focus on applying fuzzing for the automotive software. And as always, given the virtual nature of this conference, I encourage you to shoot your questions as and when they pop in your mind using the chat or the Slack channel of this talk. And if Matthew could help me picking some of the questions, that would be great. And I can hopefully spend some time in the end to go through the Q&A. So let's not have any further ado and get started. So firstly, why on earth should we fuzz automotive software? So there are different motivations for this. So if you see on your bottom right, there are different levels of automation. So where it starts getting interesting is from the automation level 3, because this is where the car as such takes more control than the user. And from 3 onwards, it's like the user is always coming out of the loop, right? So for software driving these kind of cars, it's very important that they need to have a really high assurance. And we see fuzz testing as one of the key technique which allows us to find these kind of subtle vulnerabilities as well as robustness flaws in automotive software, which are more or less about SAE level 3. And this is one of the proactive ways where we could say, hey, why not we fuzz this software continuously, like every night, and keep robustness, keep testing them for robustness. So one motivation in this sense is to be proactive and to take measures for continuously fuzzing automotive software. The next one is comes from another domain, because fuzzing of late, as you've seen also in the introductory talk from Sergey, has been very effective in finding even subtle vulnerabilities in, say, Chrome browsers and other domains, right? So in that sense, it really makes technical sense to use fuzzing, because it can also be a part of the CI/CD to find as yet another effective way of finding bug hunting and security vulnerabilities. So this is the second way where you see that, okay, this technology, this technique is very promising, and you can use it. So on this left side, you see mainly one is of the mindset where one is proactive and one thinks that fuzzing makes sense and we just do it. On the right side, there could be other motivations. The first one would be compliance. For example, there could be internal norms. A notable example here is from the Microsoft industry, where they, as a part of secure development lifecycle, already emphasize that fuzz testing could be one of the techniques that can be used in complement with other static analysis and things like this. And if we come into the automotive domain, there are future norms in the shaping now, such as ISO SAE 21434, which also highly recommend techniques like fuzz testing to be more or less used. So that would be one extrinsic motivation. And the second one comes from the customers themselves, where most of the manufacturers could emphasize that fuzz testing could be done, and basically that gets kind of enforced on you. So on this right side, what you see is that fuzzing gets more or less imposed, and you have to do it. So this is one, okay, I would say a reactive mindset, where you wait for extrinsic motivations for you to kind of roll down this fuzzing bandwagon. So there, all in all, there exists this intrinsic and extrinsic motivation. So where we stand now in automotive is that we have a mix of both intrinsic as well as extrinsic motivations. So when it comes to protocol fuzzing, there is already a high awareness that, and also requirements from many multiple fronts. So to speak, there are extrinsic motivations for doing these kind of things, and even industry-grade tools. Whereas when we have to fuzz the API or the application behind the protocol, the motivation is at the moment more or less intrinsic. And here there are excellent and notable scientific community work and open source tools, and a lot of startups who are also engaged in this arena. So this kind of more or less sums up why we do fuzzing, and there are intrinsic and extrinsic motivations within the automotive industry to do such things. So moving on, the second topic, I want to focus more on like what on earth now makes automotive software a bit different, right? So here I will go through 3 of the differences one by one to show you how these differences can also create challenges for us going down the line. So the first one is a classic case where, you know, for most embedded software, that's that of platform dependence. So if you are aware, if you already know highly portable software, which is more or less in the IT or web domain, welcome to the world of embedded software, where the software is very highly platform dependent, or you could even say it's very patriotic. So what makes embedded software a bit peculiar, and what challenges or impediments arise due to such an entanglement with the platform is what I'm going to talk next. So coming to the peculiarities, you could see that there could, on one side, there is a really high platform dependence, because this is due to also the resource constrained nature of these embedded and IoT devices, where all the bits are more or less jammed into the last possible optimizations, and then try to put this on running on this hardware. So there's a really strong dependence on a particular hardware in this sense, and that's what's also uniquely characterizes embedded software. And in the second case, when it comes to automotive, there is a very predominant, in that sense, an established practice till now, that hardware in the loop testing has taken off, and it's been kind of done extensively, right? So this also is very valid because these kind of test environments are very representative when it has to deal with the timing of the actual hardware, of the functioning of the actuators and things like this. So I would say that's another a mindset question, how to move from hardware in the loop testing to somehow do it virtually, right? So that's the second peculiarity of this kind of embedded software, what we see. And the third one is more or less dictated by most of the safety norms these days, ISO 26262, which also heavily emphasize that all the critical components, such as the compilers, which can emit code, which then are used in safety critical devices, they have to be really certified. So we have, it's very customary to use certified compilers, cross compilers in our domains. So all these peculiarities kind of also create impediments, and some of them are because of this platform entanglement or dependence. It becomes more or less mandatory to stub the software, because software has to now be stripped off, has to be made sure that the hardware dependencies are encapsulated and then taken away to test it in isolation. So first thing is that the hurdle is to create this kind of stubs and fake devices and things like this before we start fuzzing. And the second problem is also most of the open source tools these days work really harmoniously in a Linux or Unix-like environment. And to get an automotive software executed, stripped out and executed on a Linux kind of an environment is not so easy and straightforward, and it's not also possible out of the box. And another challenge comes when we see a really monstrous and humongous build chains, which are complicated, which involves code generation and things. And they require special treatment. One of my personal experience was that when we were fuzzing projects, we were trying to create fuzz targets, and we found out later that these targets which we created got kind of wiped out because the build chain was more or less rewriting the code in different stages. And this kind of also created a tricky scenario for us to get started with. And the last one is that if you look into conventional domain like fuzzing for file formats and things like this, they are, I would say, a bit easy to start with. But when it comes to automotive software, the interfaces itself are not so trivial. And this also creates a challenge in more or less creating fuzz targets in this case. So all in all, I would say in this fuzz difference creates a challenge where the entry barrier for fuzzing automotive applications is relatively higher. So this is the first one. And this also leads to, I would say, in that sense, a really high skill requirement when it comes to fuzz testing. That means to say that fuzzers these days are still more or less in the realms of experts, and they have to move more closely to users as developers as we proceed to gain higher acceptance. Then let me focus on the second aspect now. The second peculiarity stems from the fact that automotive software is predominantly stateful. So what I mean by stateful is that a set of series transitions or state transitions have to occur even before something interesting happens. So this kind of creates interesting challenges because current state-of-the-art coverage-guided fuzzers more or less target software which with single inputs, whereas stateful programs require sequence of inputs. And when trying out the sequences to find a bug could be so long that mutations could become infeasible. And on the second side, we see that there is no adequate consideration for evolving program state during input generation. And lastly, it gets more or less tricky when software runs in an infinite loop. That's usually the case with embedded systems, and they have to be reset in an appropriate way to free up resources. So all of them create an interesting challenge, and fuzzing cyber physical software is still an open concern, as we've also seen in some of the academic conferences. Therefore, we see that we need also novel techniques to look into the domain and to fuzz stateful embedded software in the automotive context. So that's the second difference, which creates this challenge of finding unique techniques. And the third one and the last one is the one which is nowadays becoming more of a rule than an exception, because the software supply chain for automotive is becoming bigger and even complex. And nowadays, it's common to also integrate third-party software, which are often available as provided as binaries from different vendors. So such a setting makes efficient white box and gray box approaches difficult or even impossible. And we need to look for how we, and if you look into the impediments, it's also not easy to see, for example, the executing automotive binaries natively require also special emulators, which are not supported. For example, the emulators which are openly available, like QEMU, Unicorn, Gempi, they don't support the architectures which are microcontroller architectures which are used in the automotive domain. So we need also, in this sense, really scalable approaches to fuzz automotive applications and even binaries, and which is often a challenge. So this more or less finishes the first part where I talked about the differences. I have to note at this point that the differences here are not exclusive for the automotive domain. It is also likely that other domains in the embedded space, like even avionics, railways, or cyber physical systems in general, also exhibit these kind of similarities. Okay, so now coming to the main part of my talk. Why should we rethink fuzzing after all? So before we start to rethink, let's first look at and even acknowledge the areas where fuzzing excels today. So fuzz testing is efficient where, for example, we have in-house software which has to be analyzed, and there's a possibility to access source code. So this is the typical realm of white box fuzzing, I would say, which is also predominant in industries these days. In other industries where even Microsoft keeps doing these kind of fuzzing on a day-to-day basis. And the fuzzing community is also doing is doing an excellent job in optimizing fuzzing in the second case, right? So this is also where fuzzing really works well, because there are really fine tunings available to create more efficient fuzzes these days, be it with orchestration, be it with grammars and things like this. So the community is more or less focusing on making fuzzers more efficient in this case, right? So, and lastly, protocol fuzzing has lifted off already. So there is already a commercial tool available, and also for these kind of fuzzing. And when it comes to software fuzzing, which are beyond protocol, we have a vibrant community of bleeding edge open source tools, mainly for software fuzzing. So these are the cases where we notice that fuzzing is really good in that sense. So all of these are valid reasons, but when it comes to applying them for automotive software, we seem to have witnessed just the tip of the iceberg here. Now, before us and underneath the iceberg exists a domain-specific problem which needs rethinking. And this is where I would say that beneath the iceberg also exist interesting problems which are specific to our domain. The first one is the case, as I spoke about, there is no homogeneous assumption that we always have access to source code, because there are also third-party binaries and so on. And going on, it's crucial to begin with to enable automotive software to start fuzzing. And then as a next step, it could be enough to even optimize it further. So I would say, to begin with, it's really crucial to get automotive projects start doing fuzzing, and then throw all the other sophisticated techniques on these kind of software, right? And the third one is that the open source tools which are available these days, they are excellent, but they impose restrictions which only a handful of automotive projects satisfy. So in our experience, at least, if we take a bunch of 10 projects, there are just 2 of the projects which require minor reworks before they can be used, before open source tools can be used on these kind of projects, right? So this also, coupled with the previously mentioned differences given platform dependence, statefulness, and among others, create significant other challenges for us to start off with this fuzzing within the domain. So another example with respect to this domain specificity here is that you could imagine software is also not just built for a specific platform, but also for a specific operating system, which is real-time in nature. So example could be different real-time operating systems which are commercially available. And you could see that the open source tools in this case more or less assume that the software runs as is on Linux. And this is not the case, because our software in most cases would also be compiled and even using the APIs or the target APIs, the system calls of these proprietary real-time operating systems, which makes them all the more complicated to kind of strip out and port it to Linux in this case. So to summarize, I would say rethinking is now required because automotive domain needs effective fuzzing to begin with that can address the domain-specific needs first, and only after achieving this, the efficient techniques could become more relevant. Okay, so now having made this statement regarding rethinking, I want to present two ideas about how my team is trying to come up with ways of rethinking. So I must, however, admit that these ideas are future work for our team here, but please consider them as more or less like a hypothesis which still requires some amount of validation. So the first one is the idea to rethink fuzzing in the context of software for cyber-physical systems. So typically you see here in the picture, a coverage-guided fuzzer will try to generate interesting inputs for software or even binary under test by instrumenting and sanitization techniques which are done on program or even binary level. And during runtime, such information which are pre made available could be used to leveraged to use even the code coverage information and to mutate even existing inputs and even maximizing code coverage. And traditional fuzzing from the IT domain or even the fuzzing for traditional software or even the IT domain, this happens mainly on PC, right? And for cyber-physical systems or even embedded system, the software has to more or less be running in a different kind of an execution environment, right? So the key idea here is to bring fuzzing and to introduce them into the execution environments where even automotive software or cyber-physical software runs. So this could be something like an emulator, which you see here. And there are really interesting research challenges in this arena. For example, if you think about cyber-physical software, which normally receives inputs from the environment, produces output for the actuators, and how would such a software, how to meaningfully create inputs for such a software and observe the outputs of such a software, right? So that could be an interesting question. And another one could be, could it be possible to more or less reduce the search phase for testing when with the information which is already available from the software in the loop environments or even plant or environment or the physics models? So that could be another interesting question. And the next one could be, how could events or how critical could be the test results in the context of the system, right? So we could find some vulnerabilities, but you need to really understand the interplay of this particular vulnerability in different application stacks within the software in order to make an assessment also on the system level. So when it comes to binary, it could also be interesting to see what could be the sanitization techniques and all the things, instrumentation that could be done like in a retrospective manner for the binaries, right? So in this case, I would say rethinking is required in the context of cyber-physical software, and there are very interesting challenges. So to sum up, we need, going further, really systematic approaches to enable fuzzing for cyber-physical software, basically in our domain. The second rethinking is to more or less anchor fuzzing firmly into the software development process. Here, our learning is that one could really excel in building an excellent fuzzing platform. In doing so, for automotive, we more or less found some initial momentum, right? So we could say that we were somewhere on top of this hill, slowly creating momentum for this fuzzing topics. But to let the fuzzing ball roll down the hill, we need something else that is other than platform to push fuzzing also with sustained momentum. So the key to sustained momentum in this case is to mainly anchor fuzzing firmly into the software development process. As you saw also in the introductory talk, Sergey also mentioned about very well-established processes within the automotive system, how the software is developed in this V model, which slowly moves towards DevOps model now and things like this. So we need to make sure that to keep the momentum, it's also required not just to build platforms, but to make sure that the software and development process also adapts and even incorporates these kind of techniques as a part of their daily CI/CD, right? So making fuzzing a part of CI/CD and anchoring it firmly to become an integral part is a very important way to rethink also to keep the momentum going further. So with this, I'm more or less coming to the end of my talk. to quickly wrap up, I spoke about these topics for you. To begin with, I mainly told what are the different motivations, intrinsic and extrinsic motivations to fuzz automotive software. And I told three differences how automotive software is different compared to other software in the IT domain. So this leads to like high entry barrier for fuzzing. We have statefulness in software and even complicated build chains and supply chains for automotive, which includes binaries, which also complicates fuzzing. And when it comes to rethinking, I would put emphasis on the fact that we want more effectiveness for our domain, for fuzzing to work in our domain, and then we can talk about efficiency in the later step. And some ideas about rethinking is to think about what could be interesting research challenges for fuzzing cyber physical software and tackling them one by one, and also at the same time trying to increase the momentum by anchoring fuzzing firmly into the software development. So in that sense, I would say cyber physical software is probably the next frontier for fuzzing. Finally, some takeaways for you. So we have more or less created an on-premise platform. As I mentioned the word platform before, this is the platform that we created within Bosch, which not just uses vanilla techniques, pure vanilla fuzzers like AFL++, libfuzzer, but also builds on top of them to support grammar, to support statefulness, to have grammars, to have fuzz orchestration. And this we have built this in order to also scale for numerous projects within Bosch, what you see on the left side. So if you are a researcher working on cool advances of fuzzing for embedded software, you could more or less package your fuzzer in a kind of in a containerized format here in the Docker, and it could also be as well a bottle in our architecture, which is called Crate, right? So if you are interested in contributing, please get in touch with me. And I would say with this, it is more or less, this brings me to the end of my presentation. And at this point, I'm glad to take your questions. And Matthew, if you could help me picking some of the questions from the chat or from the Slack, that would be great.
Okay, actually, thank you so much for the wonderful talk. It's really thought-provoking. I particularly like your rethinking bullet points. I think those are really good areas for the community to focus on. So thank you very much for that. So for the audience, if you want to ask questions, please join the Slack community, and you can then find a channel for each of the talks. For that, you click the little plus icon in your channels view, and then you can search for the name of the speaker, and you'll find the Slack channel there. So we're getting lots of questions, so unfortunately we won't be able to get into all of them, so I'll pick some out. Apologies for those who don't get read out, but Rakshit, you can go into the channel afterwards and see if you can maybe answer some more questions then. Mm-hmm. So you mentioned kind of the open source community and some drawbacks of the current solutions, and Torbjörn is actually asking how much software used in automotive can actually be fuzzed with traditional fuzzers like AFL.
Yeah, so that's also the question we asked before we started fuzzing, right? So it's really difficult to give a percentage point here, saying this percent of software is clearly. What works really well in cases is where, for example, simple things like, you start with an automotive software, you somehow have a very good abstraction within the software where you can say, this software can be eliminated of particular compiler dependencies and easily run with GCC, right? So if you have such software, which in the first place compiles with GCC, I would say you have already had an entry point, because this is very easy to compile this kind of a software, get an executable and run it on Linux and start throwing AFL++, AFL libfuzzer at it. So I would say this question at the moment, based on my experience, I would say we are somewhere around 20 to 30% level here to see, at least based on my experience. The percentage of projects which we encountered says that at least 1/3 of them could, with minor reworks, start using fuzzing, but for the rest, we need other solutions or different workarounds.
Okay, thank you. Then we have another research-related question from Paul, who asks, what research is currently active into fuzz testing embedded systems? So where do you go for cutting-edge information, Rakshit?
Yeah, so I mentioned one point because in this talk, I basically mentioned the three differences, how they differ. And in the FuzzCon in September, I also went through the solutions which my research team are working on to improve stateful fuzzing and things like this, right? So I would say in one aspect, we are already thinking about how to bring fuzzing into to fuzz stateful software. So that is one research direction. Apart from this, there could also be in the lines I mentioned in this talk, is to see how to bring also the fuzzing techniques into the execution environments where the software are running these days, because they use software in the loop simulations with plant models and environment models with different kind of models that they work to interact with physics. And it would be really interesting to see from a research point of view, what would be the entry point for fuzzing in these kind of in the loop scenarios.
Yeah, okay, thank you. Okay, sadly, that brings us to the end of our time slot. There are lots more questions audiences have and I have as well. So maybe actually you can have a look in the channel
Sure.
and answer some more questions there.
I'll
Yeah, so also if you want to ask questions but don't want your name mentioned, you can just DM me on Slack and I'll pose your question without mentioning your name. So for those who'd like to do that, please just send me a direct message on Slack. And we'll be recording all the speakers' videos. So if you would like to receive those videos afterwards, please make sure to confirm in the email that you want to get the videos. So you should have an email with the subject FuzzCon Automotive Edition. Get access to all recordings. You can just click confirm there to receive updates. You can also follow Code Intelligence on LinkedIn or Twitter for updates and more information there. Okay, now we're going to switch tracks a little bit and have our first research talk of the day. Jasmine, who is a division manager at the Max Planck Institute for Security and Privacy in Bochum, will be telling us about the human factors of secure software development, which basically is a kind of a, why do we even need to fuzz in the first place? Can't developers just do everything right? So Jasmine's research focuses on the human factors in computer security, and it centers on humans, their comprehension, behaviors, wishes, and needs. She aims to better understand how software can enhance users' lives without putting the data at risk. And her recent focus is based on the secure development process, investigating how to help software developers implement secure software and secure software development practices. Her research has shown that working with developers on these issues can really resolve problems before they even affect end users. She was a visiting scholar at the National Institute for Standards and Technology in 2019, where she researched how users of smart homes want to have their security and privacy protected. She also received the John Carrot Usable Security and Privacy Award, and her work has been honored by the NSA in their Best Cybersecurity Paper competition. So we are really hearing some cutting edge research here. She's one of the rising stars of the usable security community, and I'm thrilled to have her here today. So with that, Jasmine, the stage is yours.
Thank you, Matthew. Can you hear me, see my screen?
I can hear you and see your slides.
Awesome. All right, thanks for inviting me. I'm going to talk about human factors in secure development today. And yeah, you'll be able to very quickly figure out how this research relates to fuzzing, I think. So my main pitch whenever I give a talk is that the vast majority of all security incidents recognize human error as a contributing factor to, well, security problems. So this can involve admins, which can be system configurators, or they can have poor patch management. This can be developers who make mistakes, which will be the focus of my talk, and which can also be end users who may be using easy guess passwords or who may not comply with security warnings. So Matthew's and also my research field kind of as a pitch has this like big problem of email security that in theory has been solved in the 90s. We could have confidentiality, authenticity, and integrity in theory. What we do have is, well, not so great email security in practice. So for me, it's more common to see that people attach a confidentiality notice than that they encrypt their emails. Part of the problem for emails is just that it's hard to encrypt them. You may understand this people attending this talk, but about your parents, grandparents, or even your non-technical employees and colleagues. So another thing that has been solved in theory is authentication, right? So what we could have is strong passwords, client certificates, YubiKeys, any other type of hardware authentication. What we do have in practice is terrible passwords that are being reused all over the place. So password research has kind of tried to fix this, but it's just hard for people to remember and create 300 plus unique passwords. And then here's something where developers come in. So password managers could solve this problem and remember things for users, but they also depend on website cooperation, and websites are configured by webmasters. And yeah, you're basically supposed to do no funny stuff in order for password managers to work. So this is also not an easy fix, and it's a fix that depends on tech people getting it right. So talking about developers, they're experts, right? They should be able to do all those things, solve all the problems, and do security correctly at all times. But they happen to not always be security experts. So I don't know if you remember, but for me, this has been pretty recent. So if we think of the Heartbleed vulnerability that existed in an open source library that was widely used to implement secure network connections, and this existed for years before it was caught, even though in theory, people were able to look at this and analyze this code and find problems. But it's also not maybe developers' fault entirely, because it's also unnecessarily complicated for them to do their job. We have unsafe API defaults that may mess with their job. We may have terrible documentation that may suggest to do insecure things. And we also may have terrible tool support that, if it does support people to do something quickly, functionally, it may also be messing with their security. So in my research, I try to get away from this question of why are developers super lazy? Why can't they just, use all the right tools, do all the right things, know all the right things to do? And I'm trying to move more towards how can we make secure programming easier for people? So for the last many years, I've been studying developers. It's harder to study them because it's harder to get access to them, but it's also really impactful if you meaningfully study them, because what you do with them and what you can teach them, and if you can help or support them fix security, this just has huge impact on all the users of all their software. So let me quickly talk about some of the research results that we have been able to get. So one of the main results, which was also honored by the NSA, was that we were able to look at this saying that everyone knows that Stack Overflow is insecure, and it's a terrible idea to copy and paste code from the internet, especially terrible for security, because any code you write may eventually end up in production code. So especially for people who don't know how to really interact with the code that they may be copying and pasting, this may be a terrible idea. But no one had ever done any type of study and measured this in practice. So this was one of the anecdotes of, well, don't do this, this is terrible. So we were able to measure this. And we started with an online survey where we talked to a lot of developers that we recruited about how they program and which online help they use. And we can see that the main resource they go to is Stack Overflow, this online question and answer platform where people post questions and other people reply with code snippets. And then in a lab study, we were able to isolate which resources they were able to use to see whether or not this had an impact on the security of the code outcomes. And then later, we were able to take the results that we got in the study and look at a large amount of apps and just see if what we found actually generalized outside of our lab into the real world. What we found was that only about half of the working results that used Stack Overflow solutions were secure. This is compared to 86% of results that were using the official documentation instead. So the problem now is, like, what are you supposed to do? People are going to check online, right? So should you cut off the internet, give people a book, and then just force them to use secure resources? So no, what we really took away was that with this peer support that's not really supervised, you can get quick functional solutions, which you can't get with official documentation that doesn't have peer support, but it's less secure. So we need to integrate resources that are both helpful but also secure. So another topic that a lot of research and also mine focuses on is that cryptography is hard for developers. Even the bad guys fail at cryptography. So there were a lot of headlines where people who created ransomware for a living needed online support in actually getting their crypto right. So this is not really a motivation problem, because like, who is more motivated to get crypto right than people who may go to jail if they don't do their ransomware correctly? So the question is, if people design cryptographic APIs specifically for usability, does that lead to better security? And we investigated this research question in an online study with Python developers. And we found that depending on library and tasks, secure solutions range from around 10% to around 90%. So really depending on what people were using and what they were supposed to do with it, they were able to either do nothing securely or do everything mostly securely. And then this is really scary. 20% of the people that did these things thought their solution was secure when it was actually insecure. So we found that even usable libraries were not really good at telling people when they messed up. So they thought, oh, my code is running. This is awesome. I can send this in and I'm good. In 20% of the cases, this was actually not true. So everything was running is fine. They thought it was fine and it wasn't. So what made a difference here was if something was designed to be usable, kind of like Stack Overflow, it did help them get functionality right. So they were able to quickly get solutions. But designing for usability did not necessarily lead to really good usability. So some libraries that said, oh, we're really usable and we did this on purpose, were just not. And then also good documentation could make a difference. So if you have low-level functionality and really helpful documentation, that would help people get secure results quickly. And then also full functionality was important. So if you just wanted to be usable and you took away most of the options, then people would still not be able to solve problems. And then in real life, which is most of the code that's being written is not being written in lab studies, libraries that don't have full functionality are just not going to be used. So you're basically forced to give people the option to mess up and then document really well what they should and shouldn't be doing. So the big question is now, how do we support developers with secure development? Because as you can clearly see, if you just leave them to copy and paste stuff from the internet, the results may be software that runs. But if you think about use cases that are maybe more important than a gaming app, so if you think, for example, about cars, you just don't want something that runs on a good day, but that is not secure. So the research results that we have is that usable documentation supports secure software development. So if you're able to give developers documentation that is, of course, secure, but that's also really usable, and where they can search for problems that they can come up with, and where they get configurable code examples, that's something that can help with secure development. And then maybe importantly for this audience, tool support supports secure development. So in one of our studies and in multiple other academic studies, we were able to show that tool support that flags problems and makes easy to fix suggestions is going to be able to help developers program securely. And then a really important finding, and one that I haven't seen so much, is that organizational culture supports secure development. So in one study, we found that company security culture that is really strong and employee security mindsets co-develop and last for a long time. So we talked to people who had been working on crypto and selling crypto to governments, and they had started out in companies that had really strong security cultures and that helped them learn on the job how to have a strong security mindset. And then wherever they went, so whether they founded a startup or whether they switched jobs completely and switched fields completely, they took this strong security mindset with them. And then also, if the new company or if the new startup didn't have their own security culture, they would influence the culture and just bring what they had learned and their habits with them and help the new company develop a similar strong security culture. So this is a secure development lifecycle that in 21 interviews with crypto experts, we were able to extract from the processes that they told us they had. And basically what you can see here is that they did anything and everything in order to make sure that their code was secure and that they wouldn't be relying just on the stuff that's external, like bug hunting later or pen testing later, but that they were thinking about security all the way through their specifications and requirements and all the way through their development lifecycle. And as you can see here, testing plays a huge role. And we can see here that at least for people who are crypto experts and who sell crypto software to governments, fuzzing also plays a big role. So another thing that can support developers is warnings in libraries. So we were able to show in a study where we co-designed warnings with developers that if you have really good and really usable warnings that give actionable advice, you can show them at compile time, and then that can also help with code security, because developers will actually stop in their tracks, take the advice, and then be able to fix security problems. And mainly the focus of my research is that understanding developers' motivations and behaviors is going to be the thing that allows us to support secure development. Thanks. Finishing early. Maybe I talked too quickly. So if you have any questions, this is now already the time for questions.
Okay, thank you for that. I'm always happy to hear about the human aspects. So I already got one question via direct message. So so we have an anonymous question. Someone saying that they're working in automotive software development and the documentation is really terrible, and the company culture also doesn't value security. And you mentioned both those things as being important. Do you have any recommendations how a company can actually improve these two issues? So how can you motivate developers to write better documentation, and how can you motivate companies to develop a better security culture?
So thank you for the question. That's a really good one, and I've gotten that one before. So I feel like the main thing you need is buy-in from the top. So if you are in a company where leadership values and rewards and makes hiring decisions and makes promotion decisions based on good security and good security habits, you are probably going to be successful in instilling a good security culture in employees, or rewarding employees that already bring this good security culture. If you work in a company where and that's not just something that I'm saying, that's like a research result from other researchers that study the same field. So if you have a company that doesn't value that, or that thinks that they don't have money for this, or that just thinks that security is annoying and is not a major thing that you should care about, then it's just going to be really hard to try from the bottom up to develop these mindsets. because you may just be seen as the annoying person who holds everything up. So I feel like my advice to people at the top would be to really treat security as a core value of the company, and then make sure that actions reflect that, and that you plan enough time, money, expertise, and hiring decisions around security. But if you are if you're not one of the people who is able to make these decisions, of course you can do all the right things, but then you run into this conflict of, well, you may only have functional requirements and you only have this much time to hit them. So if you don't have fantastic tool support that does security automatically for you, without additional time, it may just be really, really hard from, starting from within the company, but not from the top, to get this security culture installed. And what was the other?
Documentation.
Documentation, yeah. So what we've been working on, and what's been really interesting to do, is the main thing would be document not for the decisions that you made. So that would be an internal document, more or less, that you write, which is important to write for people to continue, working on this project whenever you've left, or for you after 6 weeks and after you've forgotten what you did, to continue working on the project. So documenting your decisions is good, but this is not the documentation that should be visible or should be facing towards the people who are users of your documentation. So if you develop documentation for other people that are not your developers, we kind of say you're not your developer either. So you have to figure out what are their use cases, what are they going to want to do with your product, with your software, and then what do they need to know? So what they probably do not need to know is why you made decisions, but what they do need to know is what is a good example of doing the task that they set out to do. So, and then also, how can they configure this? And then majorly, if they get this error message, if they get this warning message, what are they supposed to do with it? And a really good tip is maybe to rely on data that is being created as you have your product out there already. So you can just maybe search for problems that people have had with using it, and then search for problems that people may have posted on these peer question answer platforms. And you may just be able to take the problems that people have had and really give good examples and solutions in your own documentation. And then when you do that, this is going to remain the main resource that people are going to use if they try to use your product.
Okay, awesome, thank you. Yeah, so as you know, I'm also in this field and have done some usability studies with fuzzing. And kind of one of the things which I've seen is that no matter how deep you go in the stack, the human factor is always there. There could always be more usability. Where would you see the balance between kind of helping developers write secure software in the first place and helping developers find problems after the fact? So, or let me ask it this way: do you think we'll ever get to a point where people can just write secure software without any problems?
Well, if they do, you and I are both looking for new jobs, right? So what I think is that we can make this easier, but we should also always rely on testing, right? So I feel that I feel like that's been the problem in the first place, that people are somehow convinced that things are secure and that they don't need, additional layers of testing, of having other people review or look at things. So I feel like this whole mindset of one person can get one thing correct for eternity, and we can just leave it at that. I feel like that's brought us many problems. So if I have to make a choice, and not just so that you and I can keep doing our research. I would want to say that extensive testing is a pretty good idea, and that people are really terrible at getting a thing perfect on the first try without any oversight. And I think you and I can rely on this staying this way for a long time.
That's a nice closing thought. Thank you very much, Jasmine, for your presentation. Okay, so I've seen that a few people are asking questions about Slack. So you can go to www.fuzzcon.eu, and there's a button, join Slack. And then once you're in Slack, you need to click on the little plus symbol next to channels. And there you can enter the channels for the different speakers if you want to ask any questions, or as I said, send me direct messages if you want to ask questions anonymously. Okay, so our next talk will be from Victor, who's the Global Head of Cybersecurity and Privacy in the business unit HMI at Continental. Victor is currently working at Continental Automotive and leads the security and privacy for human-machine interface business unit. This includes the governance and development of teams worldwide. He previously worked for more than 10 years in telecommunications at Nokia, in cloud computing at Cognizant Softvision, and he's a tech geek. And I can prove that because his new passion is the UNECE R155. And anyone who has a passion for UN regulations is someone you should listen to. This is going to be really interesting. And he's looking at the readiness and preparation for this standard in combination with automated driving, machine learning, and the impact of cybersecurity. So I'm really looking forward to hearing Victor talk. And with that, Victor, the stage is yours. Victor, can you hear us? Unfortunately, I can't hear you. So I think it was the Oxford English Dictionary who said the word of the year 2020 is Corona pandemic. I think it should have been, can you hear me? Because that's what I've been saying more often than anything else. So, Victor, can you give us a wave if you hear us? Okay, so you can hear us, but we can't hear you. Jacob, can you see if you can give Victor some tech support, please? Oh, or maybe is the problem on my end because I can't hear Jacob either. Oh, interesting. And potentially the problem is with Click Meeting, not with Victor's setup. Sergey, can you maybe try saying something? See if we can hear you. Okay, I don't hear Sergey either. So then I'm pretty sure that it's not the setup on Victor's side, but it's probably something to do with Click Meeting. So let's see, maybe if I mute myself, if that makes any difference. No, that did not seem to work. Okay, just bear with us with a second. We'll try and get this tech issue sorted as quickly as possible. Okay, Thomas just wrote me that he can't hear me anymore. Do others hear me? Maybe you can write in the chat. Okay, so okay, thank you. So then that is very weird. Okay, so apologies for this. We are working on it. Please bear with us. So it definitely seems like it's some problem with Click Meeting. We are working on finding out how we can solve it. Yeah, we'll hopefully get back to you soon.
That's weird. 2020 strikes again. That sounds good. So maybe I need to activate everyone.
Okay, I just heard you, Sergey. Okay, Victor, can you say something? Oh, that is not looking good. Okay, so it's definitely.
Can you hear me now?
Yes,
Yeah.
we can hear you.
Perfect.
Fantastic.
Okay, let me take all the other headsets from the ears. So
glad to have you back. So yeah, not quite sure what went wrong there. We just restarted the back end. So all I can say, Click Meeting should have used fuzz testing to make sure their software is more robust.
Okay.
So then, thank you for bearing with us. Thank you, Victor, for being patient. And with that, I'm now very much looking to your talk. The stage is yours.
Good. I just need to share now. So if you can unshare, and then I will share my screen. Good. Now I can do it. Good. So thank you, everyone, for the patience. Thank you for the introduction. Now let's see about my talk. So what I will focus on today, it's basically what we managed to achieve so far with the fuzzing in the in continental in BU-HMI, and also some thoughts about what will be the future. So the things that are worrying me and how we will be able to to secure even more our industry. So a few words about me. So I was born in Romania. I grew up in a city with one citadel and a Hollywood-like sign. So if you like CTFs, you can now try to find what was the city. I worked for 12 years in telecommunications, cloud computing, and AI, and then moved to the automotive. I was at the origin a radio network engineer, and after that I have several customer-facing roles for Chinese, French, and US customers. I moved to Germany in 2018 at Continental in BU-HMI in Babenhausen. So now a few words about the business unit that I'm in and the products that we are doing. So we are responsible for the display solutions, basically the new displays that you see in the car.
Victor, could I just interrupt you briefly? I think we're not seeing your slide. So I'm still seeing just the first slide and the slide overview and the notes.
Okay.
I'm guessing you went to full screen after you clicked share. You need to go to full screen and then click share.
Will do so. Okay. Let's show. Okay. And now let's share.
Yeah, I mean, we just had to talk about usability. This is something which has tripped me up so many times. Okay, now we're seeing the right slide.
You see the product?
We see the product, exactly. Great. Thank you.
So these are our products. I was just mentioning the head-up displays. We are now working also on the interior cameras, and this is also a reason why I'm more concerned about machine learning, because with the interior sensing and with all the new solutions that are coming now in the industry, we clearly need to somehow secure also the machine learning. Then our biggest business in the past, and I think still today, are the instrument clusters. The full digital clusters are growing as a business for us. We are entering now in the cockpit HPC solutions, and we are also focusing on sound solutions. So now, as a next step, what do we need to do to secure our product? And I liked very much the presentation from Sergey, where we highlighted the V model and the fact that we need also in the automotive to be a bit faster with testing and with all the solutions that we need to implement. It's clear that we need to bring the speed from the other industries, but we also need to be careful because a car needs to be on the road for 15 years. And then this brings a lot of additional topics that we need to be careful with. So the first point would be, and this is something that I really believe in, is to start with the boot ROM. So I believe you know that the boot ROM is a small piece of mask ROM or write-protected flash that is embedded into the processor chip. So this contains the very first code that is executed by the processor on power on or reset. If you have vulnerabilities inside the boot ROM, you will not be able to fix them without changing the hardware. I guess you've seen in the last years, even in the last months, several vulnerabilities that have been highlighted by researchers in, for example, even in the Apple products that are unfixable. This is one of those vulnerabilities that you can fix only by fully replacing the hardware. So that's why you need to be very careful on the software that you put in. Besides the fact that it needs to be really simple, the code that it's in, you also need to be very careful and to properly test it. So what we are currently doing with this, we are doing the secure code reviews for all the mask ROMs that are getting in production to be sure that there are no vulnerabilities inside. What we plan to do in the future, and this is something that where we are working together with Code Intelligence, is to try to do also the fast testing on the boot ROM software. Here, I think in Rakshit's presentation, we clearly saw what are the struggles with this. So the complexity that is added here is that usually the suppliers do not want to provide their source code because, and it's normal because it's intellectual property that they own, and then this is bringing some additional hurdles for us if we want to go in the direction of also testing the mask ROM. Then, what should be the next step beside the boot ROM? You would say that that's only a very small piece, and then there can be a lot of vulnerabilities everywhere. So there are several layers, of course, that are needed to ensure a working and secure product. I will not go in all the details about the Tara, the security concept, all the topics that you need to perform in order to make sure that your product is secure. I will focus now on the testing. And basically what we are usually doing in a project is we receive requirements from the OEMs, and then we need to make sure that they are implemented and then tested. This kind of tests that we are now applying are static testing. I guess every project is using now a tool for doing such static testing. We have the functional testing to make sure that the product really does what it's supposed to do. Then we have some regression testing to make sure that we are not introducing some vulnerabilities and some bugs for the functions that were already developed. And then we are introducing the fast testing just before the penetration testing. So this is now how we see the product life cycle if you think only about the testing. Now, what we see in the requirements coming from the OEMs, and this you can see here on the presentation, most of the requirements can be tested with functional testing. Then you have some regression testing, and then at the end you have something like 5% out of the requirements that are requesting penetration testing and static and fast testing. If you look specifically to the static and fast testing, you will see that out of the hundreds and thousands of requirements that we receive from the OEMs, only 1% of them is referring to fast testing. So this is an interesting stuff, and we will see in one of the next slides what do we get from this. And what we've also seen in the project where we worked with Code Intelligence is that if we want to make the product secure, you need to ensure first that it's properly tested, but you also need to give this to the developers. And I've liked a lot what Yasmin also presented exactly in this direction, that at least this is what I understood, that the developers are not lazy, they are not stupid, just that they need some tools because their primary focus is to develop the product so that the product works. And then the next one is to also make it secure. And that's why I believe that if we give the tools directly to the developers for checking and fixing their code, then of course our lives as the guys and girls from the security domain will be much easier. And if now we look what actually we get from and what did we get from this 1% of requirements that we receive from the OEM. So if you have a look on the distribution, so now here we have only percentages. I cannot, of course, give the exact numbers of the vulnerabilities. We got something like 57% of the findings out of the fuzz testing. We got 24% out of the penetration testing and 19% out of the boot ROM secure code review that we performed. So as you can see, vulnerabilities were discovered and fixed in all the cases. So I couldn't say that one is better than the others. I still believe that you need to perform all these tasks. But here, I think we need to focus on the hurdles that we have in the automotive business, because as Rakshit also mentioned, we cannot do fuzz testing on code that is not ours. It's much more complicated. Of course, we are thinking about solutions for this, but at this moment, we cannot do this. So that's why you need to still secure code reviews, like in the case of the boot ROM, where it's really important, and even in the development case. And you still need to have one last step with penetration testing when you put all things together and you make sure that the different libraries are not causing additional vulnerabilities. So as you can see, we need all of them. I was impressed that the fuzz testing is bringing such a big impact from the point of view of findings. It is also interesting that here what I've put in fuzz testing as findings were only buffer overflow, specific buffer overflow. So no undefined behaviors, no other bugs that were discovered by the tool. So this is basically it. You get quite a lot from fuzz testing if you do it, and the ideal case would be to do it as fast as possible, so that, and to do it iterative. So basically, for all pull requests, you need to have this fuzzing, so that you make sure that once you fix them, you will not introduce them later. Then, so now if we speak about the software complexity a bit. So I will use here a comparison, because as we were in 2020, and you see that it also hit me 2020 now. I think in the last months we all read a lot about medicine and how all these vaccines are working, and it made me think a bit about software. So if you think about software, the software is also an ecosystem of hundreds of thousands of functions that are somehow living inside the microcontroller, and they're influencing the mean time between failures. So if you do good software, probably your device will live longer. If you do poor software, it will probably crash earlier. And this is somehow also being compared with the microbiome. So basically all the living things that are in our body that scientists didn't completely understand so far. And I guess we can say this also about software. None of us, I guess, fully understand how software works. And that's why in order to understand how software can evolve, we should have the means to measure the interactions between these different functions to see what combinations are most fit. And this is basically what we are doing in the products. We are always taking different parts. We are taking from Stack Overflow. We are taking from previous projects. We put them all together and we try to make them work. Now, of course, the software that is evolving from features point of view should always be to take the most secure path. And that's why I believe that fuzzing and this kind of testing can help us in this direction, to live with this increasing software complexity, to make sure that it's still secure, even if you put all the different functions together. And then you need to have in the end a project that still works. And we don't want to hire 200 security experts to review our code. Now, why I believe that we need to worry now. So we are in the phase that machine learning is coming into the automotive industry. All the software complexity is coming in the automotive industry. We are moving from ECU specific products to cockpit to HPC products, and now there are more and more interactions between the software. And now, why worry? And this is the picture that I'm using here is coming from a public presentation done by a famous car manufacturer. Maybe you can realize which one is it based on the picture. And they were explaining how their machine learning algorithm is working, how they are implementing testing, how they are fine-tuning the algorithm, how they are introducing inaccuracies in their testing. As you can see, there is nothing about security in this presentation, in this slide that I'm showing. And it was a 1.5 hour presentation. They never spoke about security. They spoke about privacy, that they are careful with the data to be anonymized, but never a word about security. And the industry is now focused on making things work. And I think it's somehow normal now. I'm not surprised that it's like this. I think for each project, for each product, if you want to evolve, you need first to really make it work, and then to see, okay, how we protect against different attackers. But I'm still worried about what will happen in case an attacker will be able to gain somehow control of the machine learning. And what if just by sending a picture, an attacker will gain control of your car? Finding a buffer overflow or something like this, and then they will be able to control everything just by one picture. I think we've seen this before in the industry. We've seen this with iPhones crashing just by sending the wrong image. Why we believe that this will not happen, and especially if we never introduce this in the testing. So now. Also some ideas on how do we prepare for machine learning. So the figure that I'm showing, it's also from a study that was done, I think 2 years ago, so it's not so recent. Probably you've seen already the image. What the researchers were able to do is just by putting a special glass on their face, they were able to impersonate a different person just by small variations in the images that are being shown. So you can see already how easy it is in the end, and I still believe that we need somehow to introduce this kind of testing in the industry. Maybe not now, maybe in a few years, but we need to think about this, because the additional attacks that come from the arrival to the automotive are adding even more complexity to the already stringent automotive requirements. So thinking that someone will be able to get into my car and just put a pair of glasses and then drive my car, I think it's quite important. Thinking about that someone, just by putting a picture on the road, will be able to crash my car, that's also something that worries me. And that's why I believe that the testing methods are needed for covering the different attacks that are coming from the machine learning arrival into the automotive business. So we need to integrate adversarial examples in our testing. I honestly, at this moment, I don't see another way than with fast testing. So that's why this is a question that I'm raising somehow for the community to see how we can push this through. Then data poisoning, again, online system manipulation. If someone can just gain access to your system, this is also something that can hurt us a lot. Then transfer learning attack. If you can just steal what the machine learning is doing and improve it or attack it in this case, this is quite some big stuff. Data confidentiality, again, if you get access to that and then you get access to all what is there, just imagine what the GDPR will say about this. So what can we do basically? So if we think about the increasing complexity, again, I believe the smart fuzzing might be our chance to discover and fix the mutations that could be induced by an attacker. And I think this is the question that I raised to you now. I presented how it worked in the projects that we are using, but can we do this with the smart fuzzing or an evolved smart fuzzer to introduce it for machine learning, to integrate it in the CI system again for the adversarial example, so basically in the as part of the test set. And can we run it for each pull request? Can the developers then adapt and the neural networks fix the vulnerabilities find? I think this is something that I'm worried now. I don't have a solution in my head, and I'm sure that being among so smart guys and girls as I've seen before, I think we can find something like this together. So that's all from my side. I rushed it a bit to make sure that I don't overstep to the next presentation.
Well, thank you very much, Victor. That was a fascinating and scary talk. I mean, I've been worried about my car having a keyless key system, which I already am worried about. The idea of people putting up pictures and crashing neural networks in my car is horrifying. I mean, I've seen how hard it can be to convince companies to introduce fuzzing for their normal software. I dread to think explaining to people that everywhere where they use AI and machine learning, they have to do fuzzing as well. That's quite a challenge, but one we really should be looking into. That's a really excellent thought. Thank you very much. Okay, we already have some questions coming in. So from Paul, he says, earlier you mentioned that the required testing layers. I'm interested to know why formal proof, formal verification wasn't mentioned, particularly where existing tools can guarantee a wide range of software security properties, such as absence of runtime errors. So basically, he's asking, should we be looking at formal proof and formal verification more closely in the context of software testing?
We need to think that this is happening in real life products. So then you need to have tools that the developers can apply. So if we have a tool that the developer can then quickly apply, and we don't end up at the end of the project with hundreds of vulnerabilities, then yes, I'm in for all solutions to test. But we need to have tools. Otherwise, we still rely on the mind of the people. And I've seen some impressive stuff done by different experts from security companies, but this will not allow us to scale. So we need, because this is coming big in the automotive business, and we need to be able to scale. And we will only be able to scale with tools and with this kind of fuzzing solutions.
Yeah, excellent. So I have a DM question saying that, so they're also from an automotive company saying that they tried to convince people to use fuzzing but didn't get much uptake on it. Do you have any recommendations on how to convince the upper layers of a company that fuzzing is important if you are a developer who believes in fuzzing?
Yes. So what we did basically in automotive, it always works best if the OEM is requesting it. So that's then done, and there are no discussions about it. What we did in order to select Code Intelligence for our product, we did a hackathon in Babenhausen here in Germany, and we invited several suppliers. And then we showed it like this, that there are findings in the product. And then with these findings, you can go then to the management and say, hey, we have this amount of findings just in one day. We gave our software just for one day to different companies, and they come with these findings. After that, we managed to introduce it in one product, and now the findings are clearly increased. And then the direction is to show that you have the findings, and then also to speak about the UNEC regulation that is coming, and where you can clearly see that some of the mitigations that are being requested in the famous Annex 5, I would say, are pushing exactly in the direction of fuzzing. So you need to have a process to show that you don't have vulnerabilities in your code. How can you sign that you don't have vulnerabilities in your code if you don't properly test it?
Yeah, thank you.
I think this is the best approach.
Yeah. So there's another question coming in the open channel. So Maurice asks, when do fuzzing, so when you consider you've done enough fuzzing, do you go for full coverage or time-boxed fuzzing? Are there aspects you focus on when you're using time-boxed fuzzing?
So we go for time-box fuzzing, of course. We don't have unlimited time, so then we focus on that. And I believe that's why it's important to introduce it in the CI chain, because if you put it in the CI chain, then you can always fuzz your small increments and your small changes. You do it once, big for all the product, if you have all the source code, of course. And then whenever you push a change, you do as much as possible complete on that change. And like this, you are sure that you are not introducing new vulnerabilities.
Yeah. Okay, there's another question coming in over here. Could you please comment on the role of customer security testing requirements and development team derived requirements and the techniques for security testing? So how do how do customer and development team requirements play together?
Okay, so for this one, I believe that here you need to know very well your product. If you know your product and you know what are the issues, because no ECU is perfect, no software is perfect. All of them have their small flaws. And then with the Tara approach, you map the requirements that you get from the OEM with the issues that your ECU will probably have. And then with this, for sure, you will need to derive some additional requirements. And this will go again to the development, and they will need also to make sure that those are being implemented. Now, if you, so this is one point, and then for actual requirements that are coming from the software, then you need to make sure that they are tested. Otherwise, for sure, they will introduce some issues there.
Okay, so there are more questions coming in. I'm afraid we won't have time for all of them. So I have one last question for you, kind of an outlook question. Where do you see the future of fuzzing within Continental?
So what we target now, so it's first to have these solutions in all the products. So we need some sort of fuzzing in all the products to make sure that we fix the big chunk of vulnerabilities. Then we also need to make sure that we are still testing the protocols. So that's not something that we can give up. We need to make sure that the protocols are being properly tested. But honestly, I don't see how we can deliver products where we can sign that they don't have vulnerabilities without proper fuzzing testing.
Okay, excellent. So thank you so much for the talk. And again, apologies for the technical difficulties we had.
My apologies. I don't know what happened.
It was not your fault. That definitely was Click Meeting and not you. Okay, so thank you again. And now we're coming to our last talk for the FuzzCon before the panel discussion. And it's my pleasure to introduce Dr. Thomas Wollinger. Thomas has been the managing director of Scrypt since 2007. As a pioneer in automotive cybersecurity, he has brought the company from its beginnings in 2004 to a position as one of the world leading providers of system solutions for vehicle data security. So spot on for the FuzzCon Automotive Edition. He's also played a key role in guiding the company's international expansion into the core US and Asian markets. Today, his special focus is on the strategic development and integration of Scrypt's products and solutions portfolio for automotive security and beyond. Thomas holds a master's degree from the Polytechnical Institute in Worcester, USA, and a PhD with honors from the Chair of Embedded Security at the Universität Bochum. He regularly publishes articles in scientific journals and is one of the founding fathers of SCAR, the world's most renowned conference for IT security in vehicles. Scrypt has been part of the Bosch Group since 2012, and millions of Scrypt solutions are currently in use, especially in the automotive security and automotive manufacturing applications. In addition, Scrypt provides dedicated security services for corporate IT to the Bosch Group and its products. So when he says he's going to talk about the uncomfortable truths about automotive security, that is something we should really listen to, and it's my pleasure to give the stage to Thomas. I'm really interested in hearing your talk, and I hope we can hear you. And unfortunately, I can't hear you. This doesn't bode well.
Okay, let's try this one.
Yes, now I can hear you. Fantastic.
My screen as well.
And I can see your slides in full screen mode. That is fantastic.
Very awesome. So we are ready to go. Thanks so much for the introduction. It's an honor for me to speak to all of you today. As said, my talk is entitled Unpleasant Truths about Automotive Security. I brought you 5 of these unpleasant truths. There are many more, but let's say time is as it is. And so I picked the 5 that are most relevant from my point of view for this audience. So basically what happens in the next 20 to 30 minutes is we broaden a little bit the view of what was said until now. It was more about testing and how to do it and what the problems are about this. And I will, let's say, open up the discussion in the sense of starting more on the whole over automotive industry. Before I go this, I have a little advertising on the on our company. So what are we doing if you're not aware of the portfolio of Script? So basically we design security, we enable security, and we manage security, meaning on the design part is mainly consulting. As you see here, there's consulting about the strategy, we consult about trainings, we have expert consulting and different fields of security for your automotive domain, as well as security testing, which you're interested most, is the last point on the left side. So here we do all kinds of testing in let's say the specific automotive domains, so functional testing, wool scans, pen testing, of course also fuzzing. We do automated testing, but also manual testing. There is let's say from black, gray to white box testing. But also on the functionality of the car, this can be only one function that we test, one piece of software. We test a whole ECU, electronic unit in the car, but also we do testing for the whole car. So if you want to have a security test of your whole car, you can just call me later, and then we can arrange this. We have products, you see them in the middle. There are some products that are in the car, and some products are let's say for the communication with the car, but also securing the production side, as well as having services on the back end that helps to create credentials to monitor your car when it's on the road and so forth. And this comes to our managed service. So we have managed PKIs, but we also have security operations center, or we have threat intelligence and forensics, all these kind of things to help to secure, let's say, the all over system, the all over ecosystem in the car domain. Some figures and numbers, if you're interested in, we are by now 400 experts in security. We have about 240 engineers working on our own software products. They are located in 7 R&D locations, and worldwide we are present at 19 locations. As said, we are part of the Bosch Group since 2012. We were founded in 2004 as a spin-off of the Ruhr-Universität in Bochum. Okay, let's get to the point. The one introduction slide I brought with me, you see here, how did automotive industry change? On the left side, you see in the beginning, we only secured, when I started, let's say automotive security, we secured only one single ECU. Maybe it was the immobilizer, for example. The complexity of the system increases, the connectivity increases, and therefore also the attack potential, the vulnerabilities increases, and therefore, and this is why all we are here today, is also the relevant security risk, and therefore we need increasing security skills also in the automotive domain. And so I was really happy to see all these excellent ideas also this morning sessions. Okay, let's come to the unpleasant truths that we have to face in the automotive industry. So the first one, I see that there's a study from, I can give you also the sources of all these numbers I have on the slides. There's a study that in 2023, we will have 775 million cars connected worldwide. And this is through telematics and in-vehicle apps. Of course, what does arise with this is the unpleasant truth. I call this the Titanic syndrome. What is the Titanic syndrome? Is basically for those who put themselves in danger first in it. So car manufacturers without security strategy will not survive. The challenge here is you have the security is basically the enabler for the connected mobility. So you need to have the security in order to start all this new fancy stuff that we have in the car today, and we will have much more in the future to come. On the other hand, you see security is always a penalty service, meaning that the driver in your car will not see it. And for your boss, it will always be, let's say, a cost driving factor. It's something that you don't earn any more money, but on the other hand, you need to have it set up, and this only costs you money, and it's not an extra, let's say, business model for you that you can earn more money. And of course, the survival is if you don't take it serious, then there will be more earlier or later you will have a problem, and if you don't see it, you will end up like the Titanic, and we all know how this went. So with all the slides of the unpleasant truths, I give you also some hints what can be activities, actions, strategic actions that you have to do. And you see here now also the color of the slides went from black to white. So in parentheses, it's good to have a good marketing department and helps you design slides as you see here. So white is always the strategic action you can do, or we as a whole community in the automotive world, we should do. So security as a strategic task. So make sure that in your company, security is key. And as mentioned before, this needs to be covered by the management. Management needs to be behind this. Of course, you need security awareness, and this goes from, let's say, the top management to everybody in the company. Everybody should be aware that security is important and that we need to take care of it in all what we do in the company. And last but not least, this is not something that is security is not only, let's say, for the testing part of the V-cycle or for the production part or for the aftermarket. This all needs to be orchestrated. There are different implications. You have safety with you, you have processes, you have organization, you have legal stuff. All this is very complex, and companies are good. A good advice is to orchestrate this all over the whole life cycle in every stage and with all the key players in the company. Coming to the next unpleasant truth, we have seen quite a bit of extensive number growing of attacks in the car. So you see here from 2016 to 19, it's times 7. Let's say combining this is of course, if you look at the numbers, it's not really high, but combining this with the 775 million cars connected, this can really affect our whole social life in the future if we are not taking care of this. I call this one no safety without security. Basically, it's about risk of lives. It's about the life of the drivers of the car. And there's a famous quote. It was actually done by the CEO, Mr. Spess of Jaguar Land Rover. And he said, in a connected world, cybersecurity is as important for safety as the brakes. So security is as important as the brakes for safety. And I think we should all be aware of this and do our actions accordingly. So basically, the problems or the challenges that we have is we have to connect safety critical systems. So it's really about the safety in the car, and security is basically helping to push safety to a higher level. So it's really a very important point in your car. As I said, the potential of accidents or of problems are really high. If you see the number of incidents that grow over the last years, and also the size of the fleet that will be connected in the future. So even if you only have a little number of attacks that were successful, there is a study where they say in an scenario in a big city in a rush hour in the US, if all these cars are connected and somebody is really able to hack this, they speak about 3,000 deaths in one morning if there is really a significant attack. Of course, what can we do? There is some actions that we can do. It's always important to look at, let's say, original equipment. What I mean here is, of course, buy the things that you trust, and buy things of companies that are really trustworthy and where they hopefully have a good, let's say, process and people in place that have also the security in their mind. Secondly is you also have to consider the whole life cycle. And we as company are in many projects, and we always talk with our customers, and it's really important to point this out all over again and again and again. So it's really about starting with a white paper of your new function, consider security, until the development, the testing, the production, aftermarket, until your car is dead. You have to consider security. That's really important, because if you don't do this, you will not have a sound security at all, because let's say the weakest chain will always break. And the weakest kind of part of the chain will break the whole chain. And it's also not about, let's say, embedded. It's not only about the car. You also have to put more, let's say, classical IT security competence in your team and in your company. It's about the IDS, it's about the security operation centers and so forth. So that's why I also built it up in the company, this kind of expertise over the last years, because in the beginning we only were looking at embedded, but that's not enough anymore. You need all this expertise here. This brings me to my third number of unpleasant truths, the lines of code. There is a prediction that we will have in the future 300 to 500 million, depending on what kind of sources you look at, lines of code in your car. If you look at the Golf 8 that's just coming out, we have 100 million lines of code in Golf 8. I don't know if you're aware of this, but if you compare this, for example, to Boeing 787, there are only 14 million lines of code. So it's only 14% in the Boeing than in your Golf that you buy. So if you consider now that we say, let's say, between 100 and 200,000 lines of code, not millions, 1,000 lines of code, you get a problem. That means in the future, if you have like 300 to 500 million lines of code in your car, you also buy a car with, let's say, 2,000 to 3,000 errors in code. That might not all be security problems, but let's say errors on smaller and bigger size. But that's a huge number. I don't want to drive around with a car with, let's say, 2,000 errors in code. What is the challenge here? I say here it's a reasonable, let's say, consideration of risk. So basically, as we all know, we are all experts in security here. 100% security is, first of all, not possible, and you cannot afford this. Nobody will pay you to do, let's say, an unlimited fuzz testing for the next 10 years of one piece of software. So we really need to, let's say, balance the risk and the investment. So security is an investment, and on the other side, if you don't do it right, you have a risk. So it's a balance. You really need to make sure that you get the right balance here. Of the one side, you will lose business if you have too many risk, and you also will lose business if you spend too much money, because then your car or whatever you design is too expensive. And as said before, let's say it's not only about embedded, but you also need to consider things like the cloud, the infrastructure. That is also important to be considered in today's connected world. Again, let's say what are the points you can do. Of course, you can just segment your car. So you kind of say, okay, this is the safety critical part, and it's like separated, and you need to be certain considerations on security on this part. On the other hand, the connectivity is also maybe something that you have to consider, because there all the things will come in and out of the car. This is then about prioritization, meaning you really need to prioritize your security activities on the important fields, and this is for each product is different, and maybe for each architecture in the car is different. So you really have to have experts looking into this, where you really need to consider your security. Last but not least, what you can do here is the resilience in security, meaning the resilience on your systems, on your technical systems, but also on your organization and on your processes. And the dimensions you should look at is, of course, threat protection, adaptability, durability, and recoverability. So all these things are part of your resilience management, which is important to go. Come to my fourth unpleasant truths. If you look in today's world and you read the statistic of our BSI, we have about 117 million new malware per day, and from June last year to May this year, they say there were 322 new malware programs per day. So it's really a big number. Of course, this is all only considering, let's say, our normal IT. But if you look into the future, where all this Internet of Things are connected, this will also hit us in different other domains. What is the challenge here? I say here an omnipresent threat. So if you don't find the hole, somebody else will do. And let's say the evil is everywhere, and it's there. So the challenges here is, of course, we have very, very complex systems, and as discussed here already, it's also a challenge to test this. How can you fast test your systems if they are run more and more complex functions and features, and then there are more subsystems connected, maybe also with different suppliers and so forth. So this is really a challenge for our testing community, and there were some very interesting, let's say, challenges already put out this morning, for example. And you have to also make sure that you consider the lifetime. It's not like your mobile phone that you change every year and get a new one. Here we have a car, and the lifespan of this car is very, very long. So just make sure when you do your design, when you do your testing and so forth, make sure that this needs to be covered the whole life cycle. And of course, production is key. As said before, we in the last years, we consider quite a bit on securing the production, because everybody was only looking at their immobilizer in the car, but then let's say we got some problems into the car on the production side. So there are very simple things like, how do you get your credentials from your back end into your production line to end of line? This is not trivial if you want to do this securely. What can you do? And I think here we have the experts on the line. Of course, security strategy, testing strategy. So really testing, and let's say the FuzzCon itself as a platform to exchange these ideas is excellent. So I think testing from the beginning of your start of, let's say, requirement analysis, starting with your blank piece of paper, make sure security testing and security in itself, as security as function or enabler for function, as well as security testing, is part of your considerations. And of course, this needs to be done for all connected entities. So it's different ECUs in the car. It's different cars that are connected to each other. Maybe you're connected to your traffic light, but you're for sure connected to some kind of backend. And all this needs to be considered in your security and also in your security testing. So it's not only about security testing of your ECU in the car, but it's also about security testing of your backend. And as said, this needs to be done over the whole life cycle. Coming to my last unpleasant truth that I wanted to present today, and this is the regulations. We heard this at one point today. There is new regulations coming up. We didn't had a lot of regulations and standardization in the automotive security world over the last years, but now they are coming, and unfortunately they differ a little bit depending on what kind of standardization you're looking into. They differ a little bit on the different areas of the world, but anyways, we are looking into this, and UNECE and ISO is the prominent coming up. What is the, let's say, unpleasant truth behind all this is those who don't follow the rules are disqualified. So it's really, you have to follow these rules. You have to become, let's say, a player with this, following this standardization in order to be part of the market and be able to participate in the market. The challenge that will rise immediately here is, of course, the increasing complexity. You don't have only, let's say, your technical security complexity with your car and the back end and so forth, but now you have also to fulfill certain standardizations, which increases, again, your complexity in your company or in your process. Of course, with the complexity is always a fear also of over-regulation. If we have an over-regulation, at one point, you're not able to do your job anymore because you're only considering regulations. And of course, there's a high pressure to react. That can be a challenge, but can be also a chance here to convince, for example, upper management. What should you do to work against these unpleasant truths? Of course, get legal experts into your teams. They can help you to cope with the upcoming regulations and to fulfill them. Of course, the standard compliant security design is very important, but some of the, it's not only design of your technical system, it's also the design of your processes. For example, the ISO 21434 is more about processes and how you fulfill your processes. What do you need to do? And implement a cyber management system, cybersecurity management system. This is something that is that needs to be done. For example, if you look at the UNECE 29. So these are things that are new and that needs to be considered in your way forward. So basically, if you look at these 5 unpleasant truths that I just mentioned to you, so there was this Titanic syndrome, no safety without security, there is a risk, omnipresent threat, and the regulations that are out there. So all of this is something that are, let's say, we need to consider in the whole domain, let's say, of automotive security. And I'm a strong believer that there needs to be a collaboration between different parties to be actually able to cope with this as a, let's say, automotive society, automotive security domain. What what is sure is we will get more mobility. We will get more connected mobility over the next years to come. And we have to, let's say, deal with these unpleasant facts in the cybersecurity area in the automotive domain. And this is not something only for, let's say, the automotive manufacturer. It's all of us, let's say, from the tier 1, 2, and 3, as well as the security community that needs to help here. And we need to understand, let's say, what is the need for, let's say, we are able to participate in the market. We need to understand how we combine, for example, things like machine learning and human actions and security. We need to understand how we do the business, like what kind of subject to a business analysis do we need to consider here. And of course, this is this partnering. I think it's not possible to do this alone. We have to partner, for example, with people with high security knowledge. We have to partner with people from different domains and so forth. And I think it's important also, as I said, consider the whole life cycle. And in this also, let's say, society will play a role, as well as legal obligations that we will have. So each of this is important for all of us. And just to, I will end my talk with a quote from Bruce Schneier. He said, security is not a product, but a process. So I just want to put this up in order to tell you there's a lot of people on the line right now that are interested in fuzzing, in testing, in different kinds for the system and functions. But please don't forget that it's not everything. Security cannot be designed or cannot be done if we only are concentrating on testing. You also have to make sure that everything else around the testing is also done well, which is, for example, management of processes, which is including management for your security strategy, and so forth and so forth. So it's a little provocative, this statement from Bruce Schneier, but I think this maybe will flourish our discussion later on. So thanks so much for having me, and I hope I gave you a little bit insight and what I think is are facts that we all should know about automotive and where this will are developing too. And so I'm happy to receive your question, and thanks for having me.
Thomas, thank you so much. That was a fascinating talk and a nice overview of all the problems the automotive industry is facing. And particularly the last point, the legal one, seems to be creating a lot of interest. So I have a question from Paul here.
Sure.
Do any of the existing or emerging standards provide guidance on how to meet security objectives around testing, particularly where fuzz testing can be used?
Yeah, of course, this is always, let's say, I will step back one step. Let's say I'm happy that we have regulations at all. So I was preaching this for 15 years now, that, let's say, all other domains have some kind of specific security standards, regulations, at least de facto standards, and so forth. If you look in the banking industry, smart card industry, whatever you name it, there's a certain regulations already there. But in the automotive industry, I was preaching this for many years, also with different agencies and governments. And I'm very happy that we go into this direction now, because this will help all of us to make, let's say, this ecosystem more secure. Now, the question is always, if you do this standardization, how much is like, is it more a general standardization on, for example, processes, how to do things, or do we really go into the depth like testing? And so far, there's no regulation, at least I'm not aware of one. If you have one, please let me know, but I'm not aware of any of these regulations where you really have concrete things about testing, and, for example, that fuzz testing is necessary to get some kind of approval or certificate.
I think there's a new ISO standard where that was actually mentioned specifically, but it's quite new. I think Sergey mentioned that. We maybe talk about that in the panel later on a little bit more.
Yeah, if you talk about the ISO 21434, there is mentioned that testing should be part of, let's say, your process, but they don't say test your function 100, let's say 1 hour with fast testing. So it's not that concrete,
Yeah.
but they say, of course, that security in process, security testing should be considered, let's say.
Yeah, so that's actually something which I find absolutely fascinating. I mean, I studied human aspects of security, and we've done some work on how standards influence people's security behavior, and our results show the more specific, the more concrete the standardization is, the easier it is to follow. And if it's too abstract, it doesn't really help much. What's your view on that? What's your experience? Do these high-level standards really have an impact?
Yeah, I think so. The standards that we have they are upcoming now, basically, and they will be let's say mandatory. Yet starting now until, let's say, the next years to come will force people to follow this standard. And I see a lot of activities around security in the automotive domain, which is around this standard. So it's really, for example, a cybersecurity management system where most of the OEMs did not have before. They're now thinking of setting this up and really looking from an, let's say, looking into the whole system, how they create software and how the security plays part of it, and how they can manage security even after they sell their cars. So it's really a lot of activities I see, and so from my point of view, it's already good to have this standard, because it puts kind of a focus, a flashlight on security, which is important. On the other hand, we will have type approvals, that's what they call it. Like, you need to have an approval from a third party on your car, on your functions and so forth. And I think there, of course, these approvals will then also go a little bit more into the details on what you really do. And I think that's a thing that can be easily done, and it's known for many other standards that, let's say, once you have a third party that inspects you, there normally the technical experts come to you and audit you, and then you can have a discussion on what kind of security testing, for example, in this case, you should do, and what is state of the art in this regard.
Okay. So we're almost out of time, but I have one last question coming in, which is actually picking up your quote of Bruce Schneier concerning processes. And the question is, what do you see the current state of DevSecOps being in the automotive industry, and how can it be improved?
What is about DevOps, or what was the question?
DevSecOps.
Okay. Yeah. So let's say you could say that this is not a system, but a culture, let's say, and for cultures to be implemented is harder. Let's say, coming from a V cycle model, let's say software development, going to an agile, going to DevOps, and so forth. So this is let's say something is not that the management says, okay, this is a process you need to follow. This is more, let's say, changing the minds, changing the culture, changing the work style, and so forth. So I think let's say we are starting this, but from my point of view, changing culture is let's say something that needs a whole, let's say, some more years. Let's put it like this.
Yeah, that's maybe something Jasmine can pick up again in the panel discussion.
Yeah.
But for now, thank you so much for your talk. That was really
You're
fascinating, and for the answers. And now I can ask the other speakers to rejoin, so you can unmute yourself and open up your videos for the panel discussion. And also Sergey, the CEO from Code Intelligence, will be joining us for our last program point. So just as a reminder, you can join the Slack community, and there's a channel which is called Panel. So if you would like to ask any questions to the panel, just type them there, or as always, you can DM me. And if you want to receive all the videos, please remember to confirm that in the email, or follow Code Intelligence on LinkedIn or Twitter. And you can also, of course, follow any of the speakers you are interested in on LinkedIn and Twitter to stay in touch there. Okay, it looks like so Jasmine still is missing from the panel, but I say let's just start up the panel anyway. And I'd actually like to start with you, Sergey, since we've not heard so much from you. So we've seen a couple of talks about all the problems we have with security and getting that really kind of up and running. As someone working in a company who sells software testing products, do you see things in such a worrying state as well?
Not from my side. So you can hear me, right?
Yes, I can hear you.
Okay, great. Yeah, from our side, we see some changes. So when we started, like in 2018, with the first fuzzing approaches and approach automotives, things were moving slowly, and somehow, we had to do a lot of work in convincing people. But this somehow changed in the last years, basically because on the one hand, there are other industries who are talking about DevSecOps and fuzzing and all the kind of stuff and producing good results. And on the other hand, things also get easier in the automotive sector. So now more and more projects are using, for instance, Linux instead of AutoSAR or completely commercial tool chains. So there is definitely change. So I see it in a positive ways for the next few years. Obviously, there are some legacy projects which will be still continued, and I think in those kind of projects, it's not that easy to move to the new ecosystem. And this is something where OEMs, but also all the manufacturers will have a struggle. But for the new projects, I'm quite optimistic that those will, the difference to other industries will be just not as big as with the legacy projects.
Yeah, I want to add to that what you said, because there's this famous quote, I think, from Gandhi, which first they ignore you, because these were the days where people saying, okay, cars will never get connected, who knows who would never attack you, and things like this. And they laugh at you, something like, okay, you're not connected, okay, interesting, and then fight to this day, okay, this is no good, and you win. So we are in this space, I would say, where we are pretty much coming closer to this, as I was recently said, about the regulations and the awareness creation and the lot of awareness days with regulations that we are in this space where I would say there is considerable momentum going further, and then also to keep on anchoring security as a root and into all accompanying processes.
I'm having a few audio issues. Is that just on my end, or is the audio breaking up for others as well? Just my end? Okay, that's good. Okay, so Jasmine, Thomas at the end said that in the automotive industry, we're still kind of predominantly with the V model of software development, and there's a long road to go to kind of get into more agile DevSecOps style development, and that there's a big change in company culture needed there, which I think nicely comes back to your point that company culture is something really important. Have you looked at software development processes like kind of traditional V model, waterfall model compared to agile development, pair programming? Do you have any insights in how that affects programming? I seem to recall you said something about pair programming.
So I haven't looked formally into comparing outcomes of using different processes. What I think is really important to mention is that each industry has its own requirements for how agile you can be. So I feel like one example, for example, if you sell code to governments, you need to get certified. There's going to be a strong incentive to get things right really early, because once you get certified, you can't change your code, right? So that kind of takes a little bit away from being able to be agile. just because you can't really update and fix and implement new features, because what you have to do is you have to get certified each time. So I'm not an expert on the automotive industry, but it seems to me that updating software in cars seems to be something that's also done infrequently. And we can't live with, once a year, people bring their cars in for inspection, and then they're being updated. And whoopsie, this time we have like a little problem and we need to fix it again pretty soon. So I feel like certain development process models may just be really, really hard to get to if you have the requirement that you can't really patch frequently and easily, and that rolling out new features, rolling out new security fixes is really, really exhausting and expensive and comes with negative publicity. So I'm not sure whether there is like a really good solution where we can say, oh, everyone should be following, like, no matter if they're developing an app or whether they're developing something that needs to be more durable and can't be patched, everyone needs to have the same development process. Does that make sense?
Yeah, it does. Thank you. Sergey, I mean, you've gone into many companies now and helped them introduce fuzzing. What's your experience with the different development models? I can't hear you, Sergey. I think you're not muted. Yes, I can hear you now.
Okay, perfect. Yes. So, could you somehow the audio was broken? The question was the different development models, or could you repeat the question?
Yeah. So basically, when you started out saying that DevSecOps is something important, I was interested in your experience. I mean, you've gone into companies where I'm assuming they still had very kind of classical, traditional models of write the software for half a year, test it for a couple of months, then release it, and then the cycle begins again, which is probably not the current form of doing it. What's your experience being introducing fuzzing into that kind of environment? How willing are people to update their process to go into more, let's say, continuous integration-based testing?
Yeah, I wouldn't say it so much from the perspective of what kind of model, because most of the companies claim that they do agile and DevSecOps. So we have never had a company who is saying that they don't do it, but somehow they still have the security and Q&A and development departments. What we experienced with introducing of fuzzing is somehow that the developers often feel kind of offended, because if we present the results and now with the first fuzzing we find something like hundreds of buffer overflows, then the discussions with the developers start something, oh, those are not so bad, and so on. And what we experienced is that at some point we did the presentation after fixing the bugs. So basically what we did, every time we found the first bugs, we just fixed them silently and then made merge requests that the fixes were accepted. And then in the end, we started to do the presentation. And this is what fuzzing brought you. And then we tell what kind of issues were found with fuzzing. But this way, there was far less resistance. So I guess it's still a company or a developer's perspective. Now there is someone who is judging my code. And I think that when companies introduce new testing technologies, finding errors, they need to consider how to make it less painful or offensive for the developers.
Victor, are you still in the panel? Can you?
Yeah.
Oh yeah, lovely, great, thank you. So that kind of rings a bell in my memory that you said that one of the ways you kind of got your company interested in fuzzing was through the hackathon day. Can you tell us a bit more? Where did you add it in your software development process? Was it something which was kind of done at the end, or could you integrate that into your process or kind of in a shift left way?
This is now at the end. So now we are in a phase where just before the penetration testing, we run the fuzzing. And of course, the plan is now to integrate it in the GitHub so that the developers can directly use the tool, and we run it, I don't know, with the nightly builds. And after that, they can immediately see whatever issues they introduced.
Oh, interesting. Thank you. Thomas, what are your thoughts on this?
Yeah, so I think it's. Can you hear me?
Yes, we can hear you and see you well.
Okay. I think it's important to do those two things. One thing is, of course, saying where the problems are, and let's say also showing them concretely. And Hackathon is definitely one thing, or let's say testing tools like Sergey was just mentioning. So testing them and showing the problems. On the other hand, let's say also helping people and leave them not alone on let's say on the problems. So we really, as security experts, we also need to help them to solve them, because it's not, normally people don't do this on purpose. It's just what happens. And so it's something that has to be also with let's say the nature of the programmers in itself. They want to do a good job. And if you show them, okay, here's a problem in your code, well, it's normal. You have to understand it's normal. We have problems in your code. That's it. And then you have also security problems in your code. Oh man, another problem in my code. What can you do? So we need to help them and say, okay, listen, I help you here. We go together through this, and we fix this together. And then you can go to your management and tell the success story. So it needs to be, let's say, something, a balance between showing the problems and helping people to fix.
So that kind of brings us back to the human factors, which I also see in my work so many times. But one of the things which I found quite interesting in my research into fuzzing is that, unlike static analysis, developers actually felt quite positively towards fuzzing because they really noticed a benefit. So while their views on static analysis was very much, okay, I get this huge dump of messages, and then the tool says, now that's your problem. Fuzzing, while having a slightly higher initial setup cost, it was a bit more difficult to use. Once it started running, it produced helpful things. So maybe there a question to Jasmine. How much do you think kind of that the good usability or functionality of security software is important to create this shift in culture we've heard so many times, which is needed?
I really like this question. So I think if you already have all the buy-in in the world and the company invests like all the money that they need to spend and you have high expertise on developers and everyone already has a security mindset, you can get away with somewhat unusable tools, right? But this is just not the reality in most companies. So usually what you get is maybe reluctant buy-in and maybe, well, we should be doing security, but we have so many other things to do. So in this reality of no one has time to, fiddle with unusable tools, obviously you want developer tools to be as usable as possible. And then also all the time that people spend on sorting through unreadable warning messages is just time that they don't spend on fixing their code, right? So I would wholeheartedly agree that usability of tools that support secure development should be good, and that this mindset of, it's just, business to business software, or our users are experts, we're not dealing with end users, so we don't need good usability, that this is not a winning mindset. So yes, definitely the developers of secure development support tools should definitely consider usability.
Oh, very good, thank you. So actually we're having a question from the audience. Mirat is asking, if researchers find and announce vulnerabilities in automotive vehicles, it'll be more time-consuming to patch them than in other IT sectors. What if attackers take this opportunity to exploit them before they are patched? What are your opinions about this? Who would like to jump in on that one?
I guess that's the reason why we need over-the-air updates, so that we can always push the fixes as soon as possible. Of course, if they are not in the mask room.
Yeah, Jasmine, please.
And also we do, so this model of researchers find something and post it online is maybe not entirely a mindset that's reflective of reality. So usually there's a lot of responsible disclosure involved. So you are going to contact the company where you found problems and give them ample time and opportunity to fix before you publish your results. So maybe the results are open to like a really, really small subset of the research community that maybe reviews it. But usually ethical researchers, and I want to say that's the big majority of us, are going to work with companies and only publish their findings after the companies have had time to fix the problems. So it's not like we find problems, post them online, and then there's the 1-year delay where this is known and open, and companies have to basically scramble to fix it.
Yeah, Thomas. I can't hear you. I think you're still muted.
It says you're muted. So on the icon for whatever reason.
Okay, so strangely, in the other part of the interface, it says you're not muted.
Thomas, can you...
Now I can. There was no
Yes.
icon that I couldn't unmute. Now I can. Sorry.
Click meeting is not showing itself from its best side today, is it?
It's fine. That's maybe there are some hackers in the background wanting to not discuss about fuzzing things. So now you have to help me. What was the question again? I wanted to answer, but now I lost my thread. Sorry.
We were talking about responsible disclosure in the automotive sector.
Okay. Yeah. Okay.
Wait till they get it clear.
Yeah. So let's say one thing that I did over the last years, we established at Bosch not only a cert but also a P-cert, which is basically exactly the same kind of activities that you have known from the IT kind of infrastructure security world. We have teams that really can jump in once there's a problem, and we established this for products. And I think this is very important too. And many OEMs and many tier ones by now have this kind of activities, and they are also connected to each other. So really, if there is a problem, if you have somebody who found a problem in your code, in your products, that they have an expert that they can talk to and an internal process how you handle this security problem, because this is just natural, this happens. But if you are, let's say, then in a crisis modus, then you cannot work on these problems, let's say, on a very efficient and straight way. So it's very important, not only if you have problems in your IT systems, but also if you have problems in your products, you need to have processes, you need to have people that really work on this and maybe reconstruct the problem and so forth, do the communication. There's many things that you have to do once there is this problem happening. And so we should have, let's say, more, I would try to advertise for more normal behavior if there's a security problem in your products, because it just happens. Just be normal as you get some other problems in your software. Maybe your function doesn't work. Just work as a normal process, work on your security problem, fix it, and then communicate with your customers. The question was also, do you publish this or not? This is, of course, a very critical problem, and we debate this internally actually quite a bit, because we cannot just fix your problem in the car if it's on the street. It's not like your, let's say, Windows machine that is connected and you can fix every second basically with a new software. This is not possible. So it's really something that I'm trying to keep on the expert level. Should we publish this or not? And we debate this right now we debate this actually on a case-by-case basis.
Oh, interesting.
And for us, what happened, just one additional thought, fully agree with what Thomas was mentioning. Usually, as Yasmin was mentioning, we get informed by the researchers. We receive some time until we can answer, and then we speak with the OEM, we speak with the supplier if we take the software from someone else, and then of course they have all the rights to publish this, and they will probably publish it on a conference. But we always had the time to react if it came from a so-called white hat hacker.
Okay, so there's another audience question which I think Rakshit probably can give us some insights on. Torbjörn is asking, how can we develop helpful tools if we can't get our hands on automotive code, especially if constraints are very different in this domain, like tool chains are unique and so on? The situation in the non-automotive world is very different since everyone has access to the hardware. I know you've been looking at how can you get fuzzing running on Linux systems even though you don't have the hardware. What do you say to Torbjörn?
Yeah, I think that's a good remark and a good question overall. So I think the answer to this goes in the direction of something like finding a foot in the door. So I would recommend in this case, because automotive systems are in that sense more or less proprietary, so not everyone would have access to it, but you would have some pre-development divisions or R&D divisions like where I am, who are very open to these techniques, because we know the problem is big. We know that we cannot solve everything on our own. So I would say you could find these multipliers for you, get some proof of concepts, and then get started with these kind of activities, than having to always assume that, oh, you don't have access, so all you can do is just reverse engineering, right? So I would say just leverage your contacts and then try to get some testing done. I would say just start contacting people and start testing in that case.
Oh, excellent. I'd like to kind of cycle back to the how do we integrate this into the development process, because that does touch on this as well. So not only do we have the problem of this software being often run on proprietary hardware, it's also something which is usually integrated into incredibly complex tool chains. Do you see any kind of potential for kind of more openness in the automotive industry? Because I know that I've contacted companies before and have had a very hard time kind of getting a foothold with lots of NDAs being signed and similar things. And of course, as maybe Thomas also mentioned, the development process is incredibly important. Do you see any kind of ways that could become more transparent in the automotive branch? Rakshit?
Yes, of course. I think that should be the way forward now. The transparency, especially as I mentioned, I think to a reasonable extent, it's also reasonable to assume that there are so many different tools used in so many different levels, right? So it's the part for this kind of resistance, what you feel is just because be it test engineers or be it developers, they are bombarded with so many things which are apart from actually core development, what they do, right? And that's the reason why they are all the time skeptical when yet another tool pops up the radar, right? So I would say in this case, the key to really is to consider them as the very, very important stakeholders and get their buy-in from the developer level to begin with. And at the same time, you have to ring multiple levels within the organization to also get the priority and to also prioritize these kind of testing things also because of by creating awareness at the management level, right? So we need to run these things not in isolation just with developers, but we have to really try different levels of organization as well to create awareness from bottom up and top down and to anchor this firmly into the development process. So it's not just a tool issue, it's not just a usability issue, but it's also, I would say, many, many different stakeholders in this landscape.
Yeah.
Yes,
Thomas.
Yeah, I would definitely agree with what Rakshit was saying, because you also have to see that this industry is a very old industry and coming from, let's say, banding material in the beginning and not having wires and electronic in the car. And let's say this is now moving into a let's say over the last years into a software kind of industry, which is more like a handy an iPhone on wheels instead of being a car. So I think it's still, again, it's a whole kind of society, a whole kind of ecosystem that needs to move into this direction, and this just not happens, let's say, overnight. I can tell you, let's say, if when I started 15, 20 years ago with automotive security, when I gave a talk or I had a customer meeting, I was really, let's say, talking about, let's say, 80, 85, 90% about why security is necessary in this industry. And then I had like 1 slide, 2 slides where I could present my technology, and then I had to sum up, and then I was kicked out of the meetings because nobody believed me that security is important. Today you come into the game, and you have a meeting and you say security. You don't even need to explain that this is important. And if you talk about, let's say, testing, fuzz testing, pen testing, whatever, these are already, let's say, names. These are words that actually are known by the domain. They are known by the experts. They are known by management that this is important. So nowadays I can really spend, let's say, 85-90% of my time discussing about all these technical issues, discussing about how we actually make our cars more secure, how do we make our connections more secure, how do we make our back-end production and so forth more secure. I think so. There is already a big, we did a big step forward, if I can talk as for the whole community. But as you said, that your question regarding, let's say, more openness, it's still a way to go, and I really believe that we are on the right way. But we still need to work all together, and this is not only me, this is not only us here in the call. This is, as Rakshit said, this is very important. Everybody needs to be, let's say, in the boat here.
That's a really interesting point. I like how you point out that kind of the automotive industry is a very old industry, and a lot of kind of processes have grown over time. And if I look at companies which kind of are the beacons of fuzzing, there's companies like Google, Facebook, Microsoft, Cisco, they all use fuzzing really extensively to great effect. But they often have slogans like move fast and break stuff. With the automotive industry, I can understand that they don't say our motto is move fast and break stuff, because breaking things can be dangerous. Do we need a move fast but don't break stuff slogan for the automotive industry? Sergey, maybe what's your view there? Can you move fast and still be safe?
Oh, actually, maybe. The thing is that often the processes are really hard in the automotive sector, but solving the technical issues doesn't take too much time. And I think that there is a huge overhead coming from basically legacy overhead. For instance, we just mentioned with confidential, so basically we want to disclose bugs. What happens in the automotive industry compared to the normal industry, I would say, or a software industry, is that they have NDAs with thousands of suppliers. It's like the automotive industry is very proud for the suppliers. And now they have NDAs and specific agreements with all the suppliers. And now someone tells that there is a bug in there. What happens is that you have to find out who's responsible for what. And also, if you introduce something new in the development process, you need to get all the suppliers on board. So it's more like a process issue, because what we experience when we introduce things from the technical perspective, that this is far easier. So it takes less time than anticipated in the beginning, or was feared by the developers in the beginning. So so it's like legacy issues, and somehow you have to solve this chicken egg problem to get to new, faster processes. And I think there are some automotive players who don't follow those rules too much. And I mean, Tesla is one example for this, because they somehow created something new entirely. They didn't rely on the supply chain that much as the rest of the automotive sector.
Okay. I saw Victor raise his hand.
Yep, I think the UNEC regulation will help, because if you are forcing the OEM to do the type approval, then you are cascading this in the supply chain. So basically, if the OEM needs to come with a type approval, then they will cascade this requirement to the tier ones. The tier ones will need to cascade it to the several suppliers. So I think it will take time, but I think, as Thomas mentioned, we clearly improved in the last years, and it's clearly going in the right direction with the regulation. And I believe that like this, it will happen in the end. I believe we will also be forced somehow to improve because of the transformation in the direction of high performance computers, because then you will put even more software together, and then you will need to have more process ways to check the security.
And I think that's just to add on this, it's very important what you said, Victor, because let's say even if you are a supplier and you put a little piece of software into a car, and now you discover a problem in your software and you even know to whom to report to, it's extremely difficult to find out how important or how security relevant this problem is to the whole over car, right? So it might be, even if you use the standard ways of classifying your security problem in your software piece, and it might be a severe problem, you might have done a really, really bad job in security. But now you cascade this, maybe you're tier 2, you cascade this to tier 1, to Conti or to Bosch, or then to the OEM. How important or how security relevant is this little piece of software on a system level? Maybe it's not relevant at all. So all this kind of, let's say, things that you are easily be able to do on your little piece of software, it's very complex in the whole ecosystem, and is this really not an easy job, let's say, to kind of work in this together. And I totally agree with you, Victor, that UNICE is definitely the right step in the right direction.
Okay, so I would love to spend the next couple of hours continuing the discussion, but sadly our time is almost up. So I'd like to thank all the panel members again and ask each for a final call to action. And I'll go in reverse order. So Thomas, you can start with what you'd like to see as the next steps, or a call to action from you, please.
Yeah, so from my point of view, as I also mentioned different times in my talk and during the discussion, for me it's important that we all work together, that it's a common effort that we have to do, let's say, from the fuzzing community to the research community to the automotive community. Everybody needs to work together to make this happen. And for me, it's really, really important for somebody who loves security. Please don't forget to consider the whole life cycle and everything that is part of the system. Just, let's say, look into your development, look into your requirement design, development, testing, production, aftermarket, and so forth. So really everything needs to be considered, every part in the system, being from the small sensor in the car to the back-end cloud. So please don't forget that we can only win the security race here if we consider the whole system. Thanks.
Okay. Victor, your call to action, please.
Yes. So what I would like to transmit is, and I'm trying to do this every day, security in the end, it's common sense. It's software in the end. It's not something that a special group of people should do, and we just call them when we have some problems. It should be embedded in the products that we produce, and everybody needs to take care of it. Otherwise, we have no chance. So I hope that with these new regulations, with the new processes that we are adding, and hopefully with the great tools that companies like Code Intelligence are providing, we will be able to tackle this together.
Okay, thank you. Jasmine, are you still there?
Yes, hi. I think one thing what Thomas said, right? You need buy-in all the way through the development lifecycle or whatever development process it is you have, and you can't just leave out some parts. But also every single person who works on security or works on components that may be necessary for security really needs a strong security mindset, and this needs to be supported in the company from the top down. So basically, it's really important that whoever makes the decisions really makes sure that they're not just saying security is important, but that they're also investing in the usable tools, and that they're also okay with people spending time, effort, education on security, and that that's something that's supported.
Okay, Rakshit, your call to action.
Okay, my last statements. So I would say, yeah, definitely adding on to the rest of you, security is definitely a mindset issue, and it's also sometimes cultural issue. We should, in this age of connectivity, treat it as an enabler for a lot of different interesting features which would come up. And that's where I see that fuzzing being one of the core techniques for testing, or security V&V, is really ripe at the moment, and it's the time now to really start using it, because there are also interesting tools out there. So if you don't fuzz, someone else would do it. And lastly, I would say we should all just have a little less conversation, a little more action, and just start doing things, right? Okay.
Great, thank you. Okay, Sergey, your call to action.
Yeah, my call to action, I would basically agree with everyone before with the call to action that security needs to be like, is not a department, is not something what you put at the end, but it's like the entire process. And what you see in automotive, very good, that Q&A is really good, or is done extensively for years. And now basically that they would plan a similar, or I would hope that automotive is planning the same thing for security. And I definitely see a trend that it's going there, and I hope that it will finish as I am expecting that.
Okay, great. Okay, that brings us to the end. I'd like to thank all the speakers and panelists. I apologize for the technical difficulties we had, and thank you all for bearing with us. If you enjoyed the event as much as I did, I hope so very much, please follow Code Intelligence on LinkedIn, Twitter, YouTube. There will be more events like this coming in spring 2021. And thank you to the audience for all the interesting questions. Sorry we couldn't get all of them asked. I actually got quite a number of DM questions about how to introduce fuzzing. If the speakers haven't already answered all your questions, do feel free to reach out to the speakers or Code Intelligence. They will be happy to help you with your fuzzing and software testing questions and wishes. Okay, with that, we're at the end. Thank you all, and have a lovely afternoon.